The Alps are a majestic mountain range, undoubtedly shaped by nature for us to admire. However, something big is currently happening in the part of the range between France and Italy. These two countries have decided to dig toward each other, working on one of Europe's largest transportation mega projects in history. The project has a budget of around 10 billion euros, enabling millions of tons of alpine rock to be gradually transported beyond the European mountain range using advanced tunnel boring machines. And it's not just 2 or 3 of them. This mega project employs a total of 7 modern tunneling giants, which by 2027 will be operating simultaneously across 15 different sites. What's the end goal? France and Italy plan to revolutionize transportation between each other. Surprisingly, they also aim to enhance links with the Iberian Peninsula and Mediterranean coastal cities. Let's find out what's happening. France and Italy have been so closely connected for so long that a railway between them was inevitable, despite the formidable barrier of the Alps. And indeed, such a connection exists. The Turin-Modane Railway, which passes through the Frigious Tunnel. Every section of this 8.5-mile-long tunnel runs beneath the Alpine Mont Cenis mountain, making its construction incredibly difficult. No, you don't understand. It's extremely difficult because it was opened in 1871. Since then, including in the 21st century, trains have carried passengers and freight through it. Yes, the tunnel has been modernized many times, but given its location in the mountains and its age of 154 years, issues are inevitable. In fact, the issues are so severe that France and Italy struggle to make the most of being neighbors. The first thing to mention is the gradient. In Frigious, it's over 3%. That might not sound extreme, but in reality, this figure indicates reduced efficiency for the railway route through the Alps. Imagine walking down a straight road with no incline. Sounds pretty easy. Now imagine walking up a sloping road. Much tougher, isn't it? And what if every 330 feet the road climbs 10 feet? That's the kind of 3% slope the tunnel has. No wonder trains also struggle here. They need additional locomotives to generate enough power to get through the tunnel. This is a major blow to the economy. Higher expenses lead to lower returns. Worse yet, because of the slope, trains are limited to speeds of just 37 to 43 miles per hour. And time is money. You get the idea. Now let's look at the tunnel entrance. The height of the mountain route's profile and its overall dimensions weren't much of an issue before, but now there are serious limitations. For example, this height doesn't allow the use of modern high container platforms, so rail operators either have to make trains longer or transfer cargo to lower wagons before entering. The Frigious Tunnel is also single track. Yes, even though it looks double-track in photos, there's actually just one railway line inside the tunnel. Because of this, oncoming trains have to pass each other in special sidings near the portals, which cuts the daily capacity to about 60 trains instead of the claimed 80 to 90. Besides, France and Italy use different electrification systems, so they have to stop at a certain point, wait for the locomotive to be swapped, and only then continue the journey. This adds an extra 20 minutes to every trip. Yeah, there's a way to avoid this, using expensive dual-system trains. But again, that means less profits. All this points to just one thing. It's time for the 150-year-old Transalpine old-timer to retire. And retire it did. Problem is, nobody was ready for this. In August 2023, a landslide on the French side of Frigious badly damaged the tunnel. Because of this, the mountain route required, as officials say, a complex technical fix, clearing out tens of thousands of cubic feet of loose material, shoring up the landslide-weakened slope, and a complete overhaul of the damaged sections. All in all, it took 13 million euros. But that wasn't the real issue compared to the disastrous 15 months needed for the full repair of Frigious. Obviously, everyone still had to move goods somehow, even without the tunnel, so all the freight traffic was moved to 2 alpine road routes from France to Italy, namely the Wheeled Transport Tunnel, also called Frigious, and the Montegenevre Pass. Now imagine what happens when cargo that was supposed to go by railroad tunnel suddenly shifts to the roads. Yeah, a nightmare for drivers and everyone around. In the quarter following the railway shutdown, that is at the end of 2023, 371,903 trucks passed through the Frigious Road Tunnel, nearly 40,000 more than in Q4 2022. And in 2024, it was recorded that over 1.1 million freight vehicles went through the Frigious Tunnel. That's almost 20% more than in 2023. Huge traffic jams spanning many miles built up, Frustrated drivers who just wanted to cross the Alps in their cars ended up stuck for hours, waiting for the endless line of trucks to clear. Naturally, companies shipping goods through the mountains from one country to another also suffered from these jams. Estimates put the total losses at 50 million euros per year. However, when trucks and cars were stuck in traffic during the repair of the Frigious Railway Tunnel, drivers were already feeling relieved. The 150-year-old veteran might come out of retirement, but there'd be no more need to travel through it. In the same Mont Cenis mountain, a record-breaking tunnel worth $8 to $11 billion is under construction, which will be a lifesaver for freight and passengers on the route between France and Italy. The new tunnel has been named Mont Diambin, and they've announced this is the most crucial and challenging part of the Lyon-Turin rail line under construction. It'll be a double-track structure made up of 2 tubes, each 27 feet in diameter. Besides, it's really important to note that its gradient will no longer be 3% like the old tunnel, but just 0.15%. Here, you can clearly see the massive difference in this factor between the tunnels. Due to the significant reduction in gradient and the modern design, passenger trains on this route will be able to travel at speeds of 137 miles per hour, while freight trains will reach 62 miles per hour. And if the list of advantages still seems short, here's another one. The power supply inside the tunnel will be handled by the same system on both the French and Italian sides. Now for the most impressive part, the length. TEL, or Tunnel Européen Lyon-Turin. The company in charge of the whole project plans to build a tunnel stretching 36 miles. This would make Mont Diambin the longest railway tunnel in the world. But breaking the record won't be easy, and it's incredibly tough. First off, the Alps are an incredibly complex geological massif, featuring tectonic faults and a whole bunch of different geological zones: Flysch rocks, zone Subbrion gneiss, coal, zone Brion gneiss, as well as Piedmont schists. These formations are heavily deformed and mixed up with layers of gypsum and anhydrite, causing massive headaches for builders. And of course, this unique feature required large-scale preparatory work. Well before any construction started, geologists mapped the area precisely by drilling adits stretching roughly 14 miles in total. These give access to the main tunnel's path far below the mountain. For example, the 2.5-mile-long Villerodon-Bourget adit, built from 2002 to 2007, leads to the spot where huge underground chambers are being built, designed for assembling tunnel boring machines that'll head toward Italy. The exploratory audit at St. Martin de la Porte is especially important. Between 2016 and 2019, a 5.5-mile section along the axis of the future southern tunnel was surveyed there. And you know what data was uncovered? Construction's actually even harder than they thought. The explorers learned about an extremely challenging area known as the Zone Hulera, or simply put, a coal basin. This zone is characterized by fractured and displaced coal-bearing shales, which endure intense compressive stress. After getting this intel, the builders faced a serious problem. You can't drill a hole through such a layer using a tunnel boring machine. Still, that hardly would have slowed down the builders. Back in the day, there weren't any tunnel boring machines either. They used drilling and blasting and other simpler equipment to lay the way. For the coal basin, they stuck to the same idea. If advanced drilling rigs aren't suitable, they just use traditional methods. That said, even though the coal basin is the most challenging section, some other areas aren't much better. The rock there also prevents the use of the most advanced tunneling equipment, so the builder's task is to alternate between different methods. All in all, it's a complex and, as a result, tough and time-consuming job. This is where Germany shows up in the video about the tunnel linking France and Italy. Enter Herrenknecht, a world-leading maker of tunnel boring machines. Their systems are the key to France and Italy pulling off this incredibly hard tunnel project. For example, 2 identical gripper-type machines are being used to dig the 11-mile section from Villerodon-Bourget to the Italian border. These giants measure 34 feet in diameter, stretch 1,095 feet long, weigh 3,200 tons, and pack 4,900 kilowatts of power. These beasts are built for working in hard, stable rock under intense pressure at depths of up to 1.4 miles. They got the name gripper from how they operate. The machine braces itself against the tunnel walls with side clamps, then hydraulic cylinders push the cutting head forward. For example, on April 1st, 2025, a machine of this type named Viviana was launched at a French construction site. It'll be digging a 5.6-mile section of the northern tunnel running parallel to a stretch already dug by another similar machine called Federica. Viviana isn't just a drilling rig, it's a full-on mobile factory. After drilling, it automatically sets up concrete segments to reinforce the tunnel. Plus, it's got a built-in conveyor system to haul the excavated rock to the surface, streamlining the process and allowing for material reuse. And this is the robotic factory from WeBuild, where concrete segments for reinforcing the tunnel have been coming from since 2024. It really highlights the scale of the project. According to the plan, this production facility is supposed to make 100,000 lining elements, all specifically for the Alpine Tunnel. And honestly, this whole factory was built just for the Franco-Italian project. But let's get back to the tunnel itself. These kinds of passages may offer good protection from bad weather, but if something happens inside, it's a disaster. That said, it doesn't apply to the new tunnel because TELT decided it should be the pinnacle of safety. So for example, the two tunnel tubes will be connected to each other by 180 cross passages spaced 1,092 feet apart. Why? Well, if something happens in one tunnel, you can move to the other. Plus, it makes maintenance easier. Besides, the new tunnel will have 3 large underground safety stations, plus 2 similar outdoor zones. They'll be located near the tunnel portals. Each station will serve as a shelter in case of an emergency inside the tunnel, as well as a place to evacuate from if necessary. Of course, there will be stations with different equipment scattered throughout the tunnel to help during fires. Along with that, rescue teams will be on duty at certain points along the route. If someone misses the source of the fire, no worries, it'll be caught on camera, and there will be a whopping 900 of them. And of course, there's ventilation, which, by the way, deserves special mention because it's one of the most advanced and complex systems of its kind in the world. 4 ventilation shafts started construction in the Avril area of France. Each one is 17 feet in diameter and goes down 1,640 feet deep, connecting to a tunnel. The best part is that no direct human intervention is needed for the construction. Instead, they use an innovative method that involves first drilling a pilot hole from top to bottom to reach the base chamber, then widening the shaft from the bottom up using a reamer. TELT plans to finish both ventilation and other construction work on the new project by 2030. But that's not the end of it. Next comes the testing phase in 2032. That's when they'll run full-scale checks on all systems, the rail infrastructure, safety systems, ventilation under different scenarios, including simulated emergencies. And only after successfully passing all tests and getting approvals from French and Italian security agencies will the tunnel go into operation. All in all, way too many conditions have to be met for the project to start paying off on schedule. But one thing's for sure, the builders will give it their best because this new tunnel promises to open a whole new chapter in trade and passenger travel between the two countries. As you remember, the 3% slope was one of the main issues with the old tunnel. Here it's just 0.15%. A huge difference, not just in photos and animations, but in real life too. Add to that no need to switch trains and higher speeds, and you've got fantastic results. Trade and other train movements between the two countries will become way more efficient because less spending will be needed. According to some estimates, freight costs could drop by 40% thanks to the new tunnel. At the same time, the new line will allow trains with a load of up to 1,500 tons compared to the 600 to 700 tons of the 1871 tunnel. Plus, trains will run on 2 tracks instead of 1, making rail freight between the two countries a much more efficient option. Also, the completion of the tunnel will be a key step in the work on the Lyon-Turin rail route, of which Mont-Diambin is a part. And when this Transalpine route is finally finished, it'll drastically cut down the time it takes to travel between France and Italy. For example, without the new tunnel route, the trip from Lyon to Turin takes 3 hours and 47 minutes. But once the new route opens, the journey will only take 1 hour and 47 minutes. That's a whole 2 hours faster. Travel time between other cities will also be cut down. You'll get from Lyon to Milan twice as fast. Just don't be surprised if you notice fewer cars on the roads near the Alps. That's the future of road travel between France and Italy that TELT envisions. Once operational, the new tunnel is expected to take over 1 million trucks off Alpine roads each year. This won't just ease traffic, but will also cut greenhouse gas emissions by around 1 million tons annually. Plus, the new tunnel isn't just something France and Italy are looking forward to. Other countries are too, since it'll be part of the Mediterranean corridor. This corridor is one of the EU's 9 major transcontinental routes, stretching nearly 1,800 miles from the Spanish coast through France, Italy, and into Central and Eastern Europe. It links key Mediterranean seaports with industrial and logistics hubs in Northern Europe, handling up to 170 million tons of cargo a year. As you can see, the corridor cuts through the Alps, so goods had to travel. For example, through the 150-year-old Frigious Tunnel, the tunnel was a bottleneck, holding back the entire traffic flow. With the new Alpine route coming into play, everyone involved in the project and those managing the Mediterranean corridor expects big changes. Trains will move cargo from the coast inland to Europe more efficiently, which will be a motivation to increase trade by rail. One tunnel, so many benefits. Can't wait till it's finished because, let's face it, this could be a real transport revolution.